Welcome to the Ultimate SharePoint Infrastructure Best Practices session. My name is Michael Knoll, and I am a partner at Convergent Computing based out of the San Francisco Bay Area in the States. We're an organization that's been in business since 1986, helping our clients to deploy, maintain, and migrate to Microsoft infrastructure. Over the years, we've worked extensively with a lot of the major Microsoft tools, and over the past 12 years, we've been involved with working directly with SharePoint since SharePoint 2001. Myself and a colleague at CCO were actually the authors of one of the original books ever published on SharePoint, which we started writing on SharePoint 2001 and later revamped it to be released as SharePoint 2003 Unleashed. That series is now the most popular SharePoint series, and it has been released on each version of SharePoint. We have a new version of that book coming out with SharePoint 2013, so that should be out soon. So in addition to the work I do with the SharePoint product, I'm also involved in a lot of other Microsoft infrastructure tools such as SQL Server, Exchange Server, and some of the tools in the System Center stack. So this session really focuses on a lot of the best practices that I've learned and we've learned as an organization over the past decades in terms of deploying Microsoft infrastructure, and over the past 12 years in terms of deploying SharePoint itself. So it covers a lot of different topics, and we go into a lot of detail, and I'm hoping that you can take it back into your environment and use it to actually take a few best practices and directly put them in place inside your environment. So first, let's take a look at some of the new infrastructure changes that have been made in SharePoint 2013. Right off the bat, you'll note that the infrastructure requirements for the SharePoint role servers are much higher than they were with SharePoint 2010, which of course was much higher than it was in SharePoint 2007. So we have the requirement for generally around 12 gigs of RAM for just a standard SharePoint web or service application server. At a minimum, Microsoft says they'll support as low as 8 gigs, but that's only in development environments. You generally want to be at least 12 gigs of RAM, and that's a starting point. Keep that in mind. 12 gigs of RAM, 4 CPUs. That also assumes that you don't have the database role running on the same machine. If you do, you're looking at 24 gigs of RAM and a minimum of at least 4 cores that are allocated to the system. So bear in mind that the infrastructure requirements are higher, and the operating system versions which are supported include Windows Server 2008 R2 SP1 or Windows Server 2012. On the SQL side, it supports either SQL 2008 R2 with SP1 or SQL 2012, which is the version of SQL which I prefer, mainly because of some of the improvements around high availability that I'll talk about during this session. Some of the other changes, the general service application model is still roughly the same as it was in 2010. There's a few differences, however. One is that Office Web Apps is no longer run as a service application. Web Analytics got removed as a service application, and now the role of Web Analytics has been moved into the search application. And then Microsoft has come out with some new default service applications as part of an default install. You get service applications such as the App Management Service, which is used to manage the SharePoint App Store. You get Machine Translation Services, which allows for automatic translation of documents. So it sends them up to Microsoft's Bing Translation Services, and then it gets sent back down to your farm for translation. There's what's called the Work Management Service, which allows you to manage your tasks across SharePoint, Exchange, and Project, so that keeps them in sync. If you add a new task or you mark a task as complete, it gets marked across all 3 platforms. And then there's a newly revamped Access Services service application as well. In addition, Microsoft has added a new service called the Distributed Cache Service, which is installed in each server in the farm whenever SharePoint it gets installed on the machine. And that basically allows for optimization of the cache traffic. It basically improves the web views that are made to a SharePoint environment by keeping cached information in sync between the multiple servers. Microsoft also added a new service called a Request Management, or RM, that allows SharePoint to become more aware of the type of traffic that's coming into the environment, and allows SharePoint to provide a customized response to each type of traffic. So for example, you could have all of the iPad traffic that comes into an environment be sent to specific servers. Or you could also have, SharePoint redirect traffic from an overwhelmed server over to one that has less activity on it. So this it doesn't serve as a replacement for network load balancing, but it's for once the traffic gets to the SharePoint servers via a load balancer, what happens to that traffic and what SharePoint does to that traffic. Another major change that you'll see from an infrastructure perspective are the changes that have been made to the user profile sync service. Now, if you have some experience with SharePoint 2010, you'll note that this was probably the most difficult of the service applications to configure. There was a lot of gotchas in terms of how to set it up, and it required some fairly esoteric rights within Active Directory. There's now basically Microsoft has heard the complaints, and they have come out with 3 different options for SharePoint 2013. One option is to do a simple one-way sync from your directory, generally Active Directory. It's basically for those clients that just want to be able to pull the information out of AD and put it into SharePoint. So it's now much easier to set that up, and it's basically the way that it worked in 2007. The second option is the way that it worked in 2010, which is to do a possible two-way sync back and forth. Let's say you want to synchronize the phone number attribute that someone modifies in their SharePoint My Sites back with Active Directory. Well, you can do that with option 2, and basically uses the small forefront identity manager service that you've become used to using in SharePoint 2010. And then the third option is for larger enterprise clients who want to use the full forefront identity manager product, which is currently FIM 2010 R2, latest version, and that would allow you to do much more advanced meta-directory synchronization. So you can synchronize with Oracle and other LDAP providers, all within the same console. Another change that you will note is that the claims-based authentication model is now the default model in SharePoint 2013. Now, 2013 does offer support for both claims and classic mode authentication, but you'll note when you're setting up a web application that within the GUI you only have the option to set it up as a claims-based web application. The only way to set it up as a classic web application is by using PowerShell. But Microsoft has indicated that the next version of SharePoint will no longer support Classic, so it's a good idea to move off of the Classic mode authentication. Since that was a default in 2010, most organizations did choose Classic mode authentication, but to move to 2013, this effectively means that you should probably consider a claims-based migration before you even do the content migration. Otherwise, you're going to have to create that down-level web application with Classic mode authentication. A big change made from a storage perspective has been the addition of what's called shredded storage. To understand what shredded storage is, you first have to understand the way that SharePoint stores its content. And the way that it does this is through this concept of a blob, or a binary large object. Basically, a blob is a set of unstructured data that SQL Server doesn't know what to deal with. So, for example, a document is unstructured. From a SQL perspective, there's nothing that it can index, and there's no tables that are part of that. It's just a set of unstructured content that it stores within the content database as a blob. Well, 98% roughly of most of the average size of a content database in SharePoint 2010 is composed of blobs. So this is why the SharePoint 2010 content databases would get so large so quickly, is because of this concept of the blob, that the blob is stored in full, and not only that, but every version of a document is stored as a full blob. So if you had a 50 megabyte document and you were saving the last 10 versions of that document, but each version only had around a megabyte of changes, you'd still be storing 50 times 10 or 500 megabytes of content within those blobs. SharePoint 2013 introduces the concept of the shredded blob, which basically is a delta of the changes that were made between that version and the next. So it stores the original document version as a full blob, and then each additional version is stored as one of those shredded blobs that basically allows you to shrink the overall size of the content database. So if I go back to that example of the 50 megabyte document, I'm now only consuming 60 megs because it's 50 megs plus the additional 1 megabyte of changes in the next 10 versions, as opposed to the 500 megs that I would be taking up prior to SharePoint 2013. And shredded storage goes into place once you migrate to 2013. It doesn't go back and re-shred your blobs of old documents. So it'll only be moving forward that you'll see an improvement in terms of the space that's consumed by 2013. Incidentally, you can turn this off, but that has to be done via PowerShell as well, but it is on by default. And then another major change that you'll note is the addition of what's called Fast Search as the default search engine within SharePoint Server Standard or Enterprise Edition. And basically, this is the tool that Microsoft acquired several years ago that provides for a lot of enhanced search functionality, things like thumbnail previews, things like automatic metadata tagging of documents. That's now included and embedded as the default search engine within SharePoint Server. Okay, heading on to the next section, we're going to talk about some basics around and best practices around SharePoint architecture. And first, the important thing to understand is that SharePoint is effectively a three-tiered application. We briefly mentioned the service application tier previously. That's that middle tier that runs services which are consumed by multiple servers within that farm, and also by servers within other farms that may be consuming different service applications. So a common example of a service application would be search, and other ones like the managed metadata store, machine translation services, the new one that we talked about. So those all run at that middle tier. But then you have this top and this bottom tier. The top tier is the web tier, which runs Microsoft's Internet Information Services, and that's the tier that the end users connect to directly. And then, of course, the bottom tier runs SQL Server, and that's the data tier where all the data is stored, not just the content for the users that they're using, but also the databases for the different service applications as well. The reason why you need to architect around these three different tiers is that a web role server has very different requirements than a SQL server does, which has very different requirements from the service application roles. So you need to design around those things in mind. Database server is going to be much more disk I/O intensive than some of the other roles, for example, but it's going to also work with some of the operating system files in different ways, and it's going to manage the memory on the OS of those systems in different ways, which is why we generally recommend to break out these roles onto separate servers. Now, you can, of course, architect small farms, and some of the models that we've seen in the past include, especially back in 2007 and even in the beginning of 2010, a lot of people would just install everything all on the same server. That's what we'd call the all-in-one server. SQL Server, SharePoint, everything all in the same machine. The downside to that is, of course, you get a lot of contention between the SharePoint roles and the database roles. At a minimum, what we'd like to do is we like to get our clients to do the model to the right, which is where you break out the database role onto its own separate machine from the various SharePoint roles themselves. But that by itself doesn't provide for any high availability, and it also has the web and service application roles sharing the same space. So at a minimum, to provide for the high availability, you're looking at a 4-server configuration where you have 2 servers of the database tier, and then you have 2 servers that share the web and the service application roles. Things like search can be divided across those 2 servers by creating different index partitions and different query components, multiple crawler components, etc. Generally speaking, the service applications can become redundant by having them be installed on multiple servers. There are some exceptions to that. User profile sync can only run active on one machine at a time, so you have to fail it over to another one. But for the most part, you get high availability just by breaking out these onto 4 servers. If any one of those servers went down, the environment would continue to operate. Now at the SQL tier, that does assume a cluster or a mirror or potentially what's called a SQL always-on availability group, and we'll talk about that in more detail. But basically, again, if any one of these servers goes down, the end users don't lose any functionality. But the downside to the 4-server model is that you don't have the 3 tiers broken off onto their own machines. So we like to deploy what we call the best practice 6-server farm, which is where you have 2 machines at the web tier, 2 machines at the service application tier, and then 2 machines at the data tier. This keeps them all into their own separate machines, and also at the same time provides for that high availability of the connections. If you lost any one of those servers, the role would continue to run on the other machine. Now, of course, not everybody has the budget to go out and go buy 6 different physical servers for this, but that's actually where server virtualization comes into play. And I'll talk more about virtualization here in a few slides. Another model I wanted to briefly show was a 6-server model that actually is composed of 2 farms. And we're starting to see this model pop up more often because it provides more flexibility in how we deal with the service applications themselves. To give you an example why you would want to do something like this, we actually had a client where their user profile sync service broke, and Microsoft said, well, this is a known bug, it's fixed in the latest cumulative update, we'd like you to apply that. But they had strict change control in place that wouldn't allow them to apply to a cumulative update to the content for another 6 months. So they had to wait around for 6 months for the change cycle to roll into place before they could actually get their user profile sync to work properly. If you actually deploy multiple farms, such as what's displayed here, you could actually get around that because you could update your service application farm without affecting the content farm. So we're starting to actually see this more often where you might have a service application farm that's then consumed by 1 or more content farms. And then within the content farm, you'll still have a few service applications running, but those are generally the ones that just can't be consumed cross-farm, like Excel services, for example. Search, however, manage metadata, all of those get set up within that service application farm and then consumed cross-farm. And then all of the databases from both farms are stored either on the same instance or on different instances on the same set of SQL servers. And then from a scalability perspective, one of the things you'll note is that SharePoint itself is highly scalable. It was designed to be that way starting around SharePoint 2010 with this 3-tiered service application model. And what it really allows you to do is it allows you to add in more servers at a particular tier, or to break out roles onto their own dedicated machines. So if you're finding that you're making extensive use of Excel services, you can deploy some dedicated machines as part of what's called a server group that it just runs Excel services on a dedicated set of systems. From a search perspective, you can deploy multiple query servers. You can stripe index partitions across machines. It allows for full scalability of the environment. You can actually build this up into massively scaled environments. Which brings us to virtualization. I mentioned virtualization being a good tool that can be used for an architect because it gives you some versatility that you wouldn't normally have. So let's jump right into a couple different SharePoint virtualization examples that we've dealt with. And the first one is really meant for smaller environments that in the past might have just deployed all of the roles onto the same servers. So they would have deployed SQL Server and SharePoint all on the same host, on the same machine. Now what we recommend for those clients is that they then instead take that machine, turn it into a virtual host, and then deploy a dedicated database server within its own memory space and its own processor space on a virtual guest. And then you can deploy multiple farms at that point within that environment. So you could have multiple production farms, you could have a dev and a test farm. It gives you that flexibility to do that all on the same host itself. Of course, what this doesn't give you is it doesn't give you availability. If you lost the database server or the virtual host, your entire environment's down. So many organizations are looking more at a 2-server host environment that is composed of at least 2 physical hosts that then has different virtual guests running underneath it. So if you take a look at this particular model that I have listed out here, it actually shows an environment that's built to be highly available and disaster tolerant at the same time. If I lost any one of the machines listed on that page, the environment will continue to run. And that's done using SQL 2012 always on availability groups. Again, we'll talk more about that in a little bit here. But that's also done by then separating out the service applications and the web servers onto their own dedicated tiers. We've also note we have a test farm that of course is not highly available, but it allows us to test out, have a dedicated service application machine and a dedicated web machine. Another advantage to this is that it only uses two of the virtualization licenses that Microsoft provides from a Windows Server perspective. Microsoft allows you to buy either Data Center Edition or Enterprise Edition of Windows Server, and that gives you either an unlimited number of guest licenses in the case of Data Center, or 4 licenses in the case of Enterprise Edition. And then another example here just shows a mixture of both physical and virtual servers together within an environment. So this is actually more common than not, because a lot of times organizations are not necessarily too enthusiastic about virtualizing SQL servers. So in this case, the SQL tier is deployed on physical machines, whereas the SharePoint tiers are all deployed on virtual servers. So SharePoint servers make great virtualization candidates, highly recommend them. SQL less so. It still can be done, but you really have to pay close attention to how you're actually virtualizing those servers. And then from a scalability perspective, I just wanted to show this slide to kind of point out that you can use virtualization to provide for high levels of scalability. So this is actually a very large environment that's built to have multiple copies of databases split across SQL AOAGs, multiple web servers, a server group that's set up just for search itself, another one that's used to crawl and used for central admin, and then also other ones that are used for service applications, things like Excel services, split across multiple machines, UPS, etc. So again, this just gives you an idea how far you can take virtualized environments. And it's really about making sure that you are providing for the 4 hardware requirements, the 4 major hardware areas, which are, of course, network, disk I/O, processor, and memory. And you want to closely watch those areas because once you start to get into the trouble zone, in terms of available processor power, available memory, or you're starting to get disk reads and writes that go over 25 milliseconds, you start to get slowdowns within your environment. So take a close look at these virtualization performance counters, pull them using a tool like System Center Operations Manager or some other tool, but pay close attention to this. All right, so I wanted to talk next about data management, and that really starts with proper design of your content databases. What this really means is that you want to avoid scenarios where you have just a small number of content databases with a large amount of data in them, because you end up with unwieldy content sizes. So you'll have databases which are in the terabytes of size, which makes it a lot more difficult to do anything with those particular databases. So what we recommend is that you find these logical breaking points within your organization to deploy out dedicated site collections and dedicated content databases. So one area would be by department. So you could have, your home.companyabc.com/department/human resources or /IT or /marketing. And then each one of those would be a site collection within its own content database. That'll keep the data distributed across multiple content databases and try to avoid scenarios where the data gets too large too quick. A site collection cannot exist within more than one content database, which is why you really need to design this way from the beginning. Or if you already have a very large database, consider extracting some of the content out, generally with third-party tools. Microsoft does have some approaches to do that, but it's what we call a partial fidelity move of content. So it's recommended to look at the third-party space if you need to re-architect. Another thing you may want to consider from a data management perspective is this concept called remote blob storage. Now, I talked earlier about the shredded storage. This basically is it's not the same concept, but it revolves around the whole blob idea. It's basically taking that 98% of the data which is in that SharePoint content database and extracting it and putting it in an alternative storage location that is then referenced by the SQL Server, and that's where your blobs get stored. So we definitely recommend something like remote blob storage if you've got some very large data requirements and you need to move those blobs somewhere else. That'll shrink the size of your content databases and can end up with better performance overall. If you do go this space, though, I definitely recommend looking at the third-party area for this because Microsoft doesn't really have a very good solution for it that's natively out of the box. Okay, in terms of optimizing your databases, one thing to consider, which is actually quite easy to do, is you can just simply break your databases into multiple files. You can do this very simply within SQL Server just by going in and specifying which files are associated with the individual databases. So you'll note here in this particular diagram, I've got my content databases broken into 4 different files. And I've broken them up that way because I have 4 physical sockets, physical processors on the SQL Server itself. So by doing this, it improves the parallelization of the traffic, and I can get better throughput overall. Recommended to do this as well for the tempdb file. So the tempdb file is one of those files which is used by every single process that goes in and out of the SharePoint environment. So highly recommended to consider doing this for tempdb as well. And then at the same time also I'd consider doing things like breaking out and pre-sizing the databases initially to avoid fragmentation, particularly if they share the same drive space. So for example, you could go and take your content databases and pre-size them. In this diagram here, I've pre-sized it to 50 gigabytes total, 2 separate files, 25 gigs a piece, and then log files of a gig a piece. You'll note that the auto growth I changed to a fixed amount rather than a percentage-based amount, which is also a good recommendation to make. Make sure you're doing this as well for the tempdb file. The tempdb file recreates itself every time a machine is rebooted, and the default size is only 8 megabytes. So it actually can end up with a lot of locking while it has to grow that database after you reboot. So make sure you're setting the tempdb file to a pre-sized level that's approximately 20% of the size of your largest content database within reason. You generally don't want to be creating a tempdb file that's 200 gigabytes in size, for example. And then make sure you're doing SQL maintenance plans as well. At a minimum, make sure you're doing consistency checks, or what's called a DBCC. Go into SQL Management Studio, create your maintenance plans. If you're going to do a reorganize or a rebuild of the index, make sure you're only doing one and not both as part of a maintenance plan, per Microsoft recommendations. I generally do a reorganize. And then also make sure you're truncating your transaction logs on a regular basis so that they don't fill up the logs volume. All right, so I wanted to talk a bit about high availability and disaster recovery in the time we have left. Basically, there's some new options with SQL 2012 around high availability. It's a new concept called always on, and you'll note that the always on options, the 2 of which are listed at the top there, or the 3 including always on FCIs, actually give you much better RPOs and RTOs for your disaster recovery. So your recovery point objective and your recovery time objective are much better using always on. And the always-on availability groups, which is my favorite concept, is basically the idea of taking your SharePoint databases and creating multiple copies on remote SQL instances. All of those SQL instances are technically part of the same cluster, but it's a shared nothing cluster. They're not sharing any disk as part of that. All they're doing is they're sharing the name of the SQL server. So SharePoint connects to that name that is then shared between the multiple SQL servers and SQL instances themselves. So this allows you to fail over content automatically. You'll note in that diagram, for example, I have automatic failover set up with no data loss between the primary and then the secondary synchronous server within the primary data center. And then I also have another synchronous copy located in another highly connected data center. And when I say highly connected, it has to have at least a gigabit of bandwidth and less than 10 milliseconds of latency. If you don't have that kind of bandwidth or latency, you can create asynchronous copies, but that can only be done then for SharePoint content databases, so you can't actually do it for the service application databases themselves. So this is a great concept. I've got a whole slide deck on doing always-on availability groups that I'll give you a link to at the end if you're interested in this. It's definitely a concept which we've started to deploy a lot of recently. It gives you multiple copies of those databases. Okay, the last bit here that I wanted to just briefly mention before I wrap up here is the 5 layers of infrastructure security. These are what I call the 5 layers. I did this presentation up in Copenhagen, and this actually kind of drilled into more detail. But basically, these are the layers of security that people forget about. They forget to implement, and those include things like making sure that you're using multiple service accounts, using Kerberos rather than NT-Landman authentication, but also encryption technologies like transparent data encryption, at the SQL tier. SSL for securing the traffic from server to client, IPsec for securing traffic between server to server, and then inbound security using technologies like Forefront Unified Access Gateway, as well as some great technologies that are pretty easy to deploy, including Active Directory Rights Management Services, which allows you to restrict what happens to the content after it's been accessed. So you can restrict things like copy and paste, people being able to save other copies, etc. So with that said, I'd like to thank you for attending this session, and please note my Twitter tag if you have any questions. I'm Michael T. Knoll. You can also download my slide decks on SlideShare. You can find them on slideshare.net/Michael T. Knoll. And once again, thank you for having me, and I appreciate your time.